In Module 2, we're going to introduce you to some concepts around the software-defined data center. Now, this is really a high-level, 30,000-foot view of the environment, but it'll get us introduced into what we're looking at throughout the rest of the course. We'll also introduce you to some terms that we use when we're discussing vSphere so that we're all on the same page right from the get-go. So let's get started here with module number 2. Now, why is this important, obviously? Well, getting on the same page is really important when it comes to an introduction to the stuff that we're going to be spending a significant amount of time talking about here. Okay? We're going to learn about the concepts of virtualization and server virtualization in particular, where we're building virtual machines and containers on top of hypervisors. Okay? We're then going to look at some of the fundamental foundational topics around vSphere and the components that make up the vSphere suite of products at VMware. We'll also be looking at the vSphere client, which is our user interface that we use to actually control that environment, to build virtual machines, to assign storage and networks to virtual machines, and so on. Now, this module is broken up into 4 different lessons, okay? And in most of the modules or chapters that we have coming forward here, we're actually breaking them up into smaller, a little bit more bite-sized chunks. We'll call them lessons here. We'll start by looking at an overview of vSphere and virtual machines in general. And then we're going to look at how the resources that we give to those virtual machines are actually virtualized. What's the difference between a physical CPU and a virtual CPU? Physical memory and virtual memory, physical networks and virtual networks, and so on. Okay. Then we'll look at the user interfaces that we have, and then we'll have a fundamental look at ESXi itself. Now, if we were to go back and look at our organization that we as an IT team are supporting, in our case, virtual beings, in your case, the organization that you are working to support, of course. Okay? We want to be able to install and build our vSphere infrastructure so that we can support, of course, the business and the applications that the business relies upon. Okay? So let's take some requirements then. Okay? We, of course, when we're starting any project, need to gather a series of requirements. Okay. So we want to be using the latest version of vSphere. And always when we talk about a greenfield or brand new environment, you might as well use the latest and greatest stuff, of course, so that we can take advantage of the latest and greatest features and sets of features that VMware provides. In our case, that's vSphere 7. Okay? We want to build a cost-effective, leading-edge data center that is secure, that's scalable, that's high-performing, and that is highly available, so that we are eliminating things like single points of failure, so that we have the ability to respond automatically to physical hardware failures in the environment, so that we can either eliminate completely or at the very least minimize unplanned downtime that would occur in response to physical failures. Okay? We're going to look at building a vSphere infrastructure that conforms to what we know to be best practices. What VMware has gone through and said, hey, we've had success in building systems utilizing this set of knowledge and this set of best practices, which is what we would call it. Okay? In our case, we also want a second data center, right? Because why buy one when you can buy 2 for twice the price, right? So we want a second data center that serves as a backup site. And how might we accomplish that? How might we do things like data replication, business continuity, disaster avoidance and disaster recovery? Okay? So as an administrator and an architect, we have to decide how best to implement vSphere features in order to achieve these goals, right? I think that makes sense. So let's learn then all about those features and how they're architected and implemented so that we can continue to build our software-defined data center for virtual beings. So in lesson number 1, we're going to have a look at the overview of vSphere. What does it mean when we say vSphere? And what exactly is a virtual machine? We're going to try to explain this in such a way that you could explain this to your parents, right? To somebody who might be not so knowledgeable when it comes to technology, right? We're going to try to use some plain language when it comes to this. So we'll look at some basic virtualization concepts. We'll look at how vSphere in its component pieces fit into the larger software-defined data center. And then we're going to look at how to manage the environment to proactively deliver us the best availability, the best security, the best performance that we possibly can. Now, before we start any of this, and I promised a little earlier that we would look at some terms to build a glossary for ourselves so that we can create a common language around vSphere. Now, you'll see on the screen here how some of this might feel a little bit rudimentary. Okay? Operating system, applications, virtual machines. What are you talking about? Come on, we know what that stuff means. Of course we do. But if you will bear with me through a little bit of a story here about how the applications that we run to support our environment are getting the resources that they need, I think that this rudimentary discussion will really help us. So let's start kind of at this level of what's an operating system. Okay, so what is an operating system? Well, it's a piece of software, right? And it's designed most fundamentally to allocate physical resources. That's our hardware. That's our CPU, memory, networks, disk, video, sound, USB, whatever it is, right? It's designed to allocate those physical resources to the applications that we want to run in the environment. Examples: Microsoft Windows, Linux operating systems, Mac OS, right? These are all examples of operating systems that we are all very, very familiar with, okay? And we might say that, well, the operating system provides us a desktop. Well, that is a feature of an operating system, but fundamentally, right, the operating system delivers physical resources to applications. That's great. Okay, so what's an application? Okay, well, it's the software that runs on that operating system that is actually the consumer of those physical resources. Applications like Office, or applications like Chrome, or SQL Server, or whatever applications that we run in our business that support the business. This is absolutely the most important piece of the infrastructure that we are delivering that supports our organizations. Of course it is, right? Now, as an IT nerd, and I will wear that nerd badge proudly, right? I love all the tech behind it, right? I like understanding what's going on inside of an operating system. I love playing with all the physical hardware, right? And to me, that stuff is important, right? But that's just me. To the business, it's the application that we run on that hardware, of course. All right, so we understand what an operating system is, and we understand it's the applications that are consumers of those resources. So what's a virtual machine now? Okay, a virtual machine is a specialized application. Wait a minute, a virtual machine is an application? Yes, it is. A virtual machine is an application that abstracts hardware resources into software. Well, what does that mean? A virtual machine is an application. Applications run on operating systems, right? And in this case, the virtual machine is an application that runs a guest operating system. Oh, so it's a special type of application. Okay, so the virtual machine runs a guest operating system. A guest operating system like Windows or Linux. Well, what kind of operating system runs a virtual machine? If a virtual machine is an application, it needs some sort of operating system to allocate physical resources to it. Well, that's a specialized type of operating system that we call a hypervisor. Okay? And the hypervisor is that operating system that is designed to do nothing but run virtual machines. Lots of different types of hypervisors. Okay? Our ESXi is the operating system that we run, a type 1 hypervisor that runs bare metal. It runs right on our hardware, right? There's no intermediary layer between our hardware and our hypervisor. And it's right on that ESXi hypervisor that we will then run virtual machines. Those virtual machines are specialized applications that run what we call a guest operating system that then runs the applications that support our business. You can see how we're building this layer kind of from the bottom up, right? From the bottom, where we have now a host. That's the physical hardware that we run our hypervisor on. Okay? We considered using a term like server here. A lot of people think of, when we look at a physical piece of hardware, we think, oh, that's the server. But I don't really like the term server very much, because a server could mean the hardware, but it could also mean the operating system. It's Windows Server. Okay? It could also mean the application. It's a database server. It's a web server. It's a file or print server. So I don't think the term server is specific enough for ourselves. So when we talk about the physical hardware itself, we're going to use the term host. Okay? On this host, we run a hypervisor called ESXi. So now sometimes we'll take that term host and we'll call it an ESXi host. That just means it's a physical piece of hardware that's running ESXi as a hypervisor on which we will run our virtual machines, the guest operating systems, and then the applications on top of that. Okay, so that was all relatively generic, right? We had operating systems and applications and hypervisors. Okay? And the only time that we talked about anything relative to VMware was when we looked at this term called ESXi, which is VMware's hypervisor. Okay? So what is vSphere then? Well, vSphere is actually a suite of products from VMware that include the ESXi hypervisor, along with an application called vCenter Server. vCenter Server manages multiple ESXi hosts and helps to manage the interaction of ESXi hosts, multiple ESXi hosts, and the virtual machines that run on top of those hosts. So vSphere is really the combination of ESXi and the software that runs on ESXi, and vCenter Server that manages the larger environment, multiple ESXi hosts. Now, if I were to take multiple ESXi hosts and bring them all together in some sort of a new construct, we might call that construct a cluster. And a cluster is a group of ESXi hosts whose aggregate resources can then be shared by virtual machines. At VMware, we can run 64 ESXi hosts in a cluster. Okay? So take all the CPU and all the memory and all the networking of 64 ESXi hosts and group them together. And now we can sort of manage all of these aggregate resources together. And we can implement features like vMotion and HA and DRS within a cluster. So let's look at vMotion first. Actually, vMotion is a feature that you don't need a cluster for. You just need a couple of ESXi hosts managed by vCenter. And you can now, with vMotion, move a virtual machine. In fact, a powered-on virtual machine. Anytime we use the term vMotion, we're talking about virtual machines that are powered on, moving them from host to host, okay, without any interruption of service. So that's what vMotion is. It's really kind of a cool thing. And we're going to be looking in depth at the architecture of vMotion and actually experimenting with it in the labs in module number 7. Now, 2 features that are a part of our clusters are called HA and DRS. What vSphere HA does is it looks at all of our hosts, it looks at all the virtual machines that are running on all of our hosts, and it says that if one of the ESXi hosts should fail, if we have a hardware component fail, like multiple power supplies die, or CPU or memory dies, the host goes down, and the virtual machines that were running on that host go down with it. What HA will do, or vSphere High Availability, it will say, I know what virtual machines were running on that host. Let's make sure that they automatically get started and powered on and started on other available hosts. Okay? That's the fundamental feature of vSphere HA. Now, what vSphere DRS does is it ensures a little bit of a balance in the load across the virtual machines that are running on a cluster. And it says, you know, if I have one particular host that is really super heavily loaded, it's got a ton of virtual machines running on it. So many virtual machines, in fact, that I might be having performance problems. And I've got another host running over here that's hardly got any virtual machines running on it at all, and it's got plenty of resources available in terms of CPU and memory and things like that to support lots more virtual machines. Well, I don't like that idea that one host is under contention, where virtual machines are fighting for resources, but another host has plenty of resources available. Well, couldn't we automate some sort of system utilizing vMotion to move some of the virtual machines that are running on this heavily loaded under contention host to another host that's got plenty of resources available? Well, of course, absolutely. Otherwise, we wouldn't be talking about it, right? That's what we call our distributed resource scheduler. And we're going to be talking lots more about HA and about DRS in our cluster module towards the end of the class. So that's the terminology. Now that we've discussed our terminology, when we come back, we'll actually start to look a little bit deeper into what makes up a virtual machine. We'll see in just a minute.